Alright, the topic 7 review. Number 1, for the dilation with a scale factor of less than 1. So I'm going to write that as n is less than 1. So I know that my image is going to be smaller than my pre-image. I'm just writing notes as I go. But since my scale factor is less than 1, my polygon is going to get smaller once I multiply by the scale factor. And it wants to know, how do the angles and side lengths of the pre-image relate to the angles and side lengths of the image. So remember, the pre-image is larger, but if we have a similarity transformation, which is what a dilation is, these similarity transformations preserve angle measure and proportionally change the side lengths. So let's look at this here. Angles are proportional. Well, that's absolutely wrong. That's not what a similarity transformation does. It's the side lengths should be proportional. Angles are proportional. We're going to go ahead and rule that out. Angles are congruent. That's a good answer. Side lengths are larger. Remember, we're looking at the pre-image. Let's use a square for an example and say that it started with side 4 and n is equal to 1/2. That's definitely less than 1. Then my new square, it's going to have side length 2. Well, the angles are congruent in the side lengths of my pre-image, which is what it's asking us to look in terms of. Again, how do the angles and sides of the pre-image relate to the angles and sides of the image? So the side lengths are definitely larger. Let's just look at option D to make sure that maybe these two don't look right, and then we have to do a little bit more investigation. The angles are congruent is absolutely true. The side lengths are smaller. This is the result of multiplying by n less than 1. But this is what happens if we look at the image versus the pre-image. So it is going to be C. Alright, here's our scale factor. One I told you it's going to be the bread and butter of this test. Now, they were very nice to us. They had drawn 2 triangles. They're showing us that this is the pre-image and that this is the image. And of course I know that because I have Q here and I have Q prime here. Since everything is orientated in the same way, then the corresponding parts are the ones that I want to check. This is going to be 12/8 I'm going to put together. 5 and 7.5 are going together. And again, 5 and 7.5 are going together. So it's my job to check our scale factor. Now, I'm starting here and I'm going here. So I can see I went from 8 to 12, so I know I need a scale factor greater than 1. So anything that's less than 1, let's go ahead and get rid of it. 3/2 simplifies to 1.5, that's greater than 1, and 2 is greater than 1. So I really only have these two to consider now, since I know that this is getting larger. Since it's getting larger, I'm going to put my larger number on top. And this is going to give me, well, both of these are divisible by 4. 12 divided by 4 is 3. And 8 divided by 4 is 2. So it's starting to look like this is going to be my answer. But I don't want to rely on just one piece of evidence. We always shoot for at least 3 in this class, and conveniently, that's what we have. The nice thing being, the other 2 are exactly the same. So I got to ask myself, is there a number that multiplied by 2 is 5 and multiplied by 3 is 7.5? Because I don't have my calculator on me, so I can't just punch it in. Well, I know that 2.5 times 2 is 5, and I know that 2.5 times 3 is 7.5. So if I divide both of these numbers by 2.5, I get 3/2, and this is it. At home, with your calculator readily available, and I guess mine is too since I'm on the computer and it has one built in, let's just double check my math there. So I'm going to turn off my annotation tool. I'm going to put 7.5 divided by 5, and I should expect 1.5, and that's exactly what I got. So this is in fact the right answer. Number 3 comes at us again with another dilation question. This one is actually pretty straightforward. It wants to know what are the coordinates of the image 2, 4 dilated by 1/2. So basically right here, remember, this is in the form of d scale factor. And since I have nothing after my scale factor in the subscript, this is at the origin. So I'm going to just take very easily this coordinate and multiply it by 0.5. So it's going to look like this. 2, let's do this, times 0.5, comma, so right, 2 times 0.5, and then I have to do my 4 times 0.5. And that's going to give me my new x and y coordinate. So 2 times 1/2 is 1, and 4 times 1/2 is 2. So my final resting place for my image of this point is 1, 2. Alright, here is one that says to change this graph, take triangle XYZ and dilate it by a scale factor of 2. Again, just like in question number 3, we don't have a center of dilation, so we know it's going to be at 0, 0. This is a very nice thing for the test makers to do for us, since they didn't give us any vertical or horizontal lines where we could just count along the number line and then dilate it. Now, question 3 is very similar to what we're going to do for question 4. They're just not handing us the coordinates. They did hand us the scale factor, and we're just going to simply find the coordinate of each of our points. And then to find our prime, we're just going to take those and dilate them by 2. And we'll have our answer. So let's go to this color. Y is at 1, 2, 1. X is at -1, 2. And Z is at -1, -2. Now I'm going to take each of these numbers and I'm going to multiply them by 2 to get my prime. So I'm going to bring it down here. X prime is going to look like this. -1 times 2, comma 2 times 2. And this is going to give me -2, comma 4. Let's go ahead and plot it on the graph just so you can see it. -2, 1, 2, 3, 4. This is x prime. Let's look at y prime now. Y started at 2, so I'm going to multiply that by my scale factor of 2, comma, my x was 1, so I'm going to multiply that by my scale factor. Here I'm going to get 4, 2. If the order that in which I wrote these is confusing, it's just remember, the order in which we multiply by does not matter, and we're going to get the same answer. This is 4, 2. So let's go out to 4, 2, 1, 2, 3, 4, 1, 2. And then for our last one, we have Z. We already used a green. Let's go with this color. Z was at -1, so we're going to multiply that by 2, comma 2, and we're going to multiply that by 2, and this is going to give me -2, comma 4. And if I graph that, Z should be -2, so this should be -2, and this would be -4. So 1, 2, 1, 2, 3, 4. Now, did I make a mistake here? Yeah, I omitted this when I copied my original coordinate. Now it's a very easy mistake to catch because it would make no sense for z to be up here, because there definitely would change the scale factor between all of my points. Now I can finish this construction, which you don't have to do on the test, and just connect my dots. And that is the same shape that I had, not as expertly put together, but that would be exactly twice the side length of the original triangle. So your final answer is going to basically be this right here. You're gonna want to put in your points and then graph them and move on. Question number 5 wants us to determine which of the composition of transformations that maps triangle LMN to triangle L prime, M prime, N prime is the right one. So before I even start, I'm going to verify whether or not the triangles kept their orientation and that their corresponding parts are drawn so that they're in the same position. So L and L prime are at the bottom here, M and M prime. So I know now there's no rotation and no reflection. Well, let's say this. There's no single. There could be a series of reflections happening here that would reorientate it back to its original position. And now I'm going to look at my answer options. And the first thing I'm going to do is just see, do we have a single rotation or reflection in our answers? And if we do, we can roll those out immediately. And the nice thing about that is this reflection across the r-axis would change the orientation, and L and L prime would not be corresponding right off the bat. So those are gone. Now, realistically, and with no problem here, I'm going to answer this without doing everything. I just can look at these two options that are left and decide, was this an enlargement or a reduction? Of course, here, this answer gives me an enlargement because it's greater than 1. And this answer means I have a reduction. The whole trick here to make this really easy on yourself is to know that M to M prime went from the smaller to the larger, so we know this is answer option A. All right, really easy to do the process of elimination to get this one done correctly. Before we move on to question number 6, let me make sure that I stop you on what is kind of a natural approach as you're learning these types of problems to do. And let's make sure we don't make that mistake. We know we have to do our dilation of 2. So my side lengths are all going to double. Well, if this is 1, right, then this should be 2. And then if this is 2 units, this should go to 4. But if I draw this triangle and I try and use this translation, I'm going to go over 1 and up 3. 1, 2, 3. My M doesn't quite make it. I'm a whole 1 up and 1 over away. This is not what you want to do, because what you have to consider is you didn't actually dilate my L at all. So we actually have to do something that we've done in previous problems here. And these two problems are priming us for this problem. Remember here, we had to dilate each of our coordinates. So let's do that before we move on. I'm going to find L. And remember, this isn't quite L prime yet because I haven't translated it. This is just a result of the dilation. So I'm going to say L intermediate, or that intermediate step. I'm going to have M and M intermediate and N intermediate. My point for L is 1, 1. And don't forget, our scale factor for the answer that we've already determined is going to be right based on the 4 options we have is 2. So my intermediate step for L will be at 2, 2. M is at 1, 2. double check that. And since my scale factor is 2, that M intermediate is going to be 2, 4. And for N, I am at the point 1, 2, 3, 1. So with that scale factor, I'm actually going to end up at 6, 2. So let's go ahead and make sure we highlight the ones that we want to graph. That's going to be L intermediate, M intermediate, and N intermediate. L intermediate is going to be at 2, 2, so let's put that there. Oh, let me get rid of that. Just keep it as clean as possible. 2, 2 is 1, 2, 1, 2. That's L intermediate, so I'm going to put Li there. M intermediate is at 2, 4, so we already know that's 2, 1, 2, 3, 4. And N intermediate is all the way out to 6, 2. So let's see here. Let's do the 2 first. 1, 2, and then 6. 1, 2, 3, 4, 5, 6. Now already, I can see that this is going to be fitting our translation here much more nicely. I need to be able to go up 1 and over 3 to map either my L intermediate, my M intermediate, or my N intermediate onto. Now, since the translation is a rigid motion, if I can show one of these works, then all of them will work. And for this, I want to go over 1 to the right and up 3. So 1, 1, 2, 3. And my M intermediate does map onto my M prime. And all my other ones will, of course, too, since this is a rigid motion. So I wanted to show you this. I want to make sure you guys see it this way, just in case maybe you're given one that's not multiple choice. You have to multiply by the scale factor based on the coordinate before you translate. You can't just double the sides like I did the first time, because you're not considering a dilation for L or where that's going to move to. Remember, this is written as a dilation by 2 from center, so of course it's going to move away from the center. Remember, enlargements always move away from their center of dilation, while reductions move towards their center of dilations. So if you're not having movement on L, you haven't accounted for the scaling up or down of that point, and you're not going to quite do it properly. Even if you do double it in size, it won't be in the correct place on the graph. All right, question number 6. What are the coordinates of U prime for the transformation of the, well, we're going to do a translation 3 to the left and up 1, composed with a dilation of 4. And then it gives me triangle TUV with its coordinates. Now, these tests are timed, and we're preparing for an EOC that's timed. If it's only asking for this one U prime coordinate, I'm not going to consider anything with T, and I'm not going to consider anything with V. There's no graphic here that's going to help me verify my answer if I do it with the other ones, right? There's nothing here that tells me, or I can use my clues if I do anything with these, that's going to help me find the answer to this. This would just be more practice during the test, but all your practices already happened in the homework. So I'm only going to use the point U. I'm going to go ahead and recopy it here as -8, 3. Now, one more time, and I don't think we ever have to talk about this in this class again. When I read this, I read it left to right, because we're not going to break the conventions of English. But when I work it, I go right to left. So that means I have to dilate first, then translate to get this right. So I have a scale factor of 4. I'm going to write it out like this. Actually, let me get rid of this. Just remember, you always dilate, or you always do your first transformation based on what's on the right hand side, and that's that. So I'm going to rewrite this as 4 times this. And if I distribute that in, I'm going to get -32 comma 12, right? 8, 16, 24, 32. and 4, 8, 12. Now I have the translation, -3 on my x plus 1 on my y. So I'm going to just put it under here as -3, comma, plus 1. -32 minus 3 is -35, and 12 plus 1 is 13 for a final resting point of -35, comma, 13. I will give you guys a little behind the scenes knowledge here. There's 3 forms of the test, and there just happens to be 3 points up on the screen. I wouldn't be surprised if, since this is form B, we're using the middle letter, and form A will probably use T, and form C will probably use V. Alright, number 7. This is pretty much straight out of the notes. Label each statement true or false. The one I'm going to go with first is that last one. All circles are similar. We said this a bunch of times. I've kept saying it. I've been saying it. We talked about quarters being scaled to the size of tires, clocks being scaled down to the size of tires, a bunch of things, right? Sorry, clocks down to the size of quarters, not tires. So we know that all circles are similar. We even briefly talked about in some classes where we had the time why that is, but just know all circles are similar. All right. I wrote yes. It's asking true or false. So let's say not yes, but true. Similarity transformation that maps one circle onto another must include a reflection. Why? If I have this circle and I have this circle, they're definitely similar, but there's nothing that tells me I need to reflect at any point, right? Would we even know without labeling points on the circle if we reflected it? Absolutely not. So that's going to be false. And here, if there is no similarity transformation that will map one circle onto another, then all circles can't be similar. So they're kind of leading you this way to the truth. But if we spot this first and we know that's true, this is a direct contradiction of, option B and C, or I guess 7A, 7B, 7C are contradictions of each other. So we know if one's true, the other must be false. All right, number 8 is all about making sure we understand what it means when they say given S, T, U, and D, E, F. That means S corresponds to D, T corresponds to E, and U corresponds to F. And if we know that, this becomes so much easier. It wants to know what is the measure of angle D. Well, D and S are corresponding, so if we know what S is, we know what D is. And there's nothing else to that one. Now, if you don't remember this, and for some reason a lot of times when you're learning geometry, this never actually clicks with you, and then you come back and you say, I'm getting ready for the SAT and I want to brush up on geometry, and then I say it to you again, you're like, oh yeah, I remember that, or oh yeah, that's right, and then it all clicks. This problem is given away in the way that the triangles are written. So we know that. The other trick is to do this. I can find the scale factor between each side so that I can find my correct orientation so that they're all corresponding to each other. And then I'll see that this comes down to be 46. So this 8 and this 20 is how I would find that. So 20 divided by 8. Turn off my annotation tool. 20 divided by 8 is 2.5 this time. And then I can say here, what would this one, ST, go to? ST goes to DE. So is 6 times 2.5 15? Well, 6 times 2 is 12. And 6 times 0.5 is 3. So that is, in fact, 15 is equal to 15. So that's the harder way to do it. But if you know how to read these, it's a dead giveaway on how this one would work. This problem right here is another great example. If we know how to read and we understand why the order of the letters matter when we're talking about polygons. We can do this one much easier. If you don't understand, you're going to have to draw each of these out and make sure you label them in the proper order. And I'll, of course, do that for you, but I want to show you the faster way to do it. Here it says L divided by R, well, those are corresponding, is equal to the measure of M divided by S. Since they're the same angle, L and RR and M and SR, that's going to give me a scale factor, or it's not even a scale factor, right? Because we're looking at angles. Saying the word scale factor is inappropriate here. But the ratio here, or the quotient of those, since L is equal to R and M is equal to S, is just going to give me 1 equals 1. So that's going to be a definite right answer. Let's look at B now. LM over RT, well, let's see how those correspond to each other. LM is here, but look, RT is this bridge, right? The T goes back to the R. Since I can't underline them consecutively, this can't possibly be right. These are different parts of the triangle. This doesn't tell us that triangle LMN and RST are regular triangles or equilaterals. So this isn't given or definitely necessary. Let's assume that these are scalene so that we have a better chance at we're making the most general statement, right? It may be true for some cases, but it's definitely not true for all cases. Here, N and T are equal. N and T fall in the same place, so they, of course, are the corresponding parts. And we know in similar triangles, which is what that symbol means, the angles that correspond to each other are congruent or equal. So C is the right option. Now, C would not be the right option if these were side links that we're talking about, like we are in D. Let's look at MN. So MN is the second part here, and ST is the second part. And this says MN is equal to ST. But remember, in these types of problems, the side links are proportional, not equal. D is not a right answer. Now, if it was LMN is congruent to RST, then D would be right. But we have to be very careful that when we're talking about similarity, we're not using equal or congruency symbols between our side links. Alright guys, before we move on to number 10, let me not just leave you hanging with a thought process or a way to think about these without actually seeing it. For those of you who are really uncomfortable or haven't quite mastered this whole reading, comparing the corresponding parts, that's perfectly understandable, especially this year. It's been a rough year with everyone being half at home, half there, half everywhere. So I went ahead and already marked the right answers, and I drew two triangles. I can see that the corresponding angles are congruent. I have 30 and 30, 90 and 90, 60 and 60. Again, you can't trust your eyes. These are definitely not 90-degree angles, but this is just for a proof of concept. Here, this side went from 1 to 4, so my N equals 4. Then I check it there. 3 times 4 is 12. 2 times 4 is 8. So these are without a doubt similar triangles, and that was the requirement for this question. LMN is congruent to RST. I wrote my letters by starting at the bottom left and going in a clockwise fashion around the triangle. LMN, RST, and just like I can see here, L and R need to be in the same spot on both triangles. They are. M and S must be on the same spot. They are. And N and T are corresponding, and I've drawn them to be that way. This is exactly what we were saying to do in our heads just a few minutes ago in this same video. So now let's look at why the measure of angle L divided by the measure of angle R is equal to the measure of angle M divided by the measure of angle S. And we're going to do that over here. Angle L is 30. Angle R is 30. Angle M is 60. And angle S is 60. 30 divided by 30 gives me 1. 60 divided by 60 gives me 1. And again, I can see that A is in fact true. Now let's look at B. LM, which is 3, over RT, which is 8. And we can already see these aren't the corresponding parts. And I can already see that the scale factor is going to fail me there. But we're going to double check. Maybe they're doing the same thing, right, on these. Ln is 2. And that needs to go over RS, which is 12. Well, 3/8 does not equal 1/6. And since we constructed these to be similar, we forced them, we got to pick the numbers. We know that these ratios should in fact be true, and since they're not, B is not an answer for us today. And then we have C. C is the measure of angle N, which is 90, is equal to the measure of angle T, which is also 90. And that's good to go. Now D, this symbol and this symbol usually cause conflict with side lengths, unless we're looking at equilateral triangles or regular polygons. Here we're definitely not. We constructed these not to be regular or congruent. So let's look at what MN is. MN is 1, and we're saying that that needs to be the same as ST, which is 4. This is not true. If this had the similar sign, we'd be picking that answer. Make sure we're paying attention to our signs when we're solving this problem. Alright, number 10 says, which condition would prove DEF is similar to JKL? And then I get this proportion thing, right? Or this ratio. What I'm going to do, instead of trying to make sense out of all these and then see what I can do, I'm looking at the diagram before I do anything else. I can see that D is congruent, angle D is congruent with angle J. And I can see here that those are corresponding, so that's a good thing. Here I can see there's a scale factor between DE, and that is if I just multiply it by 1/2 or divide it by 2, I get KJ. And DE and KJ or JK are corresponding as well. So looking at this picture, there's two things I can use. I can use our rule for angle-angle similarity, or I could potentially use our rule for side-angle-side similarity. Side-side-side similarity is not going to work because here it's only giving us, this is a pick one, and none of these are giving us two more sides, so side-side-side is off the table. So what I'm going to do is see if I have any angle options here. This is side length, 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 side length. So I am forced to do side angle side. Fortunately for these, we've already shown that what's given are the corresponding parts. And I know for side angle side it has to be the included angle. That included angle is the angle in between the two sides that form it, right? Or the two line segments that form it make the included angle. So for this would be my other side, and for this one would be my other side. So if I can show, let's call this x1 and x2, if I can show that there is similarity between x1 and x2, then I do have similar triangles by the side angle side criteria, or in this question they're using the word condition. I would have written personally and said in class which criteria would prove, but they're using condition, that's fine. And now I just need to ask, well, which of these are talking about DF and JL? Not this one. This one is not, and this one is. Now I have to ask myself, how do I read this right here? DF, let's look at B. 2 DFs is equal to 1 JL. Basically what that's saying is if JL is 1, then DF is 2. Or just 2 times JL equals DF. So basically that's our scale factor. Now, my scale factor is, for DE to KJ, 14 to 7. So my smaller one, if this is 1, we know this needs to be 2. And that is exactly what this one's saying, so we are going to pick this one. This is just saying that for every 1 DF we have 2 JLs. We can already see that that's definitely not going to be the case. Otherwise, this would be 14 here and 28 here. Since this is getting smaller, we need it to be getting smaller. The DFs must be larger than the JLs. So for number 10, we've got B. All right, number 11, a classic. It says, given VXY, and at least if we read the directions, it helps a lot because it does tell us which triangles we're looking at. VXY is this large one. So VXY, and I'm only gotten to this part in the directions, and I'm going to go ahead and draw it. VXY, VY is 88. I have no idea what XY is, but I can see here that XV is 72 plus some number. We've already used X and Y on the screen, so let's go with R. So this is just 72 plus whatever R is. And then it says, and VWZ. VWZ is this little one, so I'm going to draw it underneath. I'm going to make sure that it's orientated in the same way. I can see that this angle is 90 degrees and this angle is 90 degrees. So I'm going to make sure I have my 90-degree angles together. The nice thing about them giving us 90-degree angles here is we know the inside of a triangle adds up to 180. So every one of the other, well, both of the other two angles must be less than 90. So automatically the orientation for our congruent parts to map onto each other, once I do my similarity transformation, is already set up for us. I'm going to go ahead and draw this as VZW. And I need to start filling in some of this. Well, we've already defined VW to be R. Let's make that an actual R. Here we can see that VZ is 88 minus 55. And again, we know nothing about VZ or XY. Is it asking for XY? Let's find out. Hopefully not. What is VW? Okay, perfect. We set up our variable to be VW without even reading it, and that's what it's asking us. Now, the way we've drawn this means we've already got it set up to be ready for our proportion. This is just 72, right, over 88. We don't like those 8s. All right, put the parts of the triangle, force them together, over our unknown divided by 33. This is going to give me 88R is equal to 33 times 72 plus R. I'm going to bring our work over here where I have a little bit more room. And I'm going to pull up the calculator really quick to find out what 33 point times 72 is. All right, that is 2376. So 88R is equal to 2376 R, right? Nope. And then plus 33R. Now I can subtract 33R from both sides. This is going to leave me with 55R is equal to 2376. Divide by 55, and R is going to give me 43.2. So then VW is equal to 43.2. All right, number 12 and number 13, same question, basically, different numbers. Maybe we're identifying different parts. Remember what we said in class. To solve for these, it's just inside squared is equal to long times short. So here it wants to know what JL is. That's the whole thing, so we need to be careful with that. So we need to find this and then add it to that to get our answer. Now I'm assuming it's going to be it's going to be this answer. And that's just because if I take 8 plus 4.5, I'm going to get 12.5. And they're probably trying to get you to just say that this answer, right? So be careful when you're answering these. Now, this might be a wrong piece of intuition here, but I do try and point out things that I see that might be helpful for you to kind of start being aware of on these types of tests. But before we do anything, let's identify our inside. That is 6. So this is going to be 6 squared is equal to the long side, which is 8, times our short side. Let's call it, well, x. So this is going to give me 36 is equal to 8x. I know 8 times 4 is 32. And then if I have 4 more, that's going to give me half. So this is going to be x equals 4.5. So this is exactly what I said. Be careful. I've got x equals 4.5. I wrote x there. I'm so used to just solving for x and moving on. Well, we know this part only is 4.5. Now I need to use the segment addition postulate, which I'm going to write out again just so we can see it. That's Jm plus Ml is equal to JL. And since I'm looking for JL, I need to add those numbers together. Jm is 8. Sorry to put them in the wrong order. Plus 4.5, and that is 12.5. All right. So that little gut feeling I had there ended up being a good thing to be wary of. Not going to call it a trap, but this might be a prompt to help you make a little bit of a mistake there and being a little hasty in choosing your answer. So make sure you understand the directions and exactly what's being asked of you. Number 13, very similar problem. We're still going to use inside squared is equal to long times short or short times long. It doesn't matter the order. This time my inside is my unknown, so I'm just going to write it as x squared equals, well, 2 times 8. X squared is equal to 16. Take the square root. X is equal to plus or minus 4. But this is geometry and we're talking about length, and length can't be negative. So we are going to have x equals 4. That x equals negative 4 doesn't make sense. In Algebra 2, you're going to learn about extraneous solutions. And those are solutions that are arrived at through the math, but they are not, they don't work for the actual problem, right? In the real world, they don't make sense. In math, we don't have to follow the rules of the real world. But when we're in geometry or certain types of problems where we're taking measurements, observations, making predictions, those need to be founded in the real world. And since we can't have a negative length, we call that an extraneous solution. I can plug it into my inside squared equals short times long answer, and it'll come out right, but it doesn't make sense in the real world. All right, so we have a theorem that told us if we have a right triangle and we draw an altitude that originates at the right angle, then it'll create 2 new triangles, and all 3 of these triangles we now have on our screen will be similar to each other. So let's look at the questions. Which are similar to MKL? Well, LKJ would be. LMK is this one, so they can't be similar. They are congruent. And MLJ would be similar. So the reason we have one no here when I said all 3 triangles are similar to each other is if I pick a triangle, the other 2 are similar to it, but obviously the one that I chose is going to be congruent to itself. So it's all in the understanding here of the difference between similarity and congruency. If my scale factor in a similarity transformation is 1, I'm not looking at similarity at all. I'm looking at congruency. This is the same as saying, if I were to try and say that MLK and LKM are not similar, that would be the same as me saying that 1 and 1 times 1 are different numbers, and we've opened a massive can of worms by doing that. Alright guys, let's look at this one. It says what is the value of x, and we've got this triangle here, and at the end of chapter 7 we got a theorem that lets us relate the left side and the right side of a triangle if this midpoint is parallel to the base. And basically what that theorem told us is if we take the left-hand side small number and divide it by the big number, and I do the same for the right-hand side, I will create the proportion that will allow me to solve for x. Here the smaller side is 5 over 2x minus 8, and here I have 3 over x minus 3. And I can set those equal to each other, and I can start solving. Here I'm going to have 3 times 2x minus 8, and here I'm going to have 5 times x minus 3. This is 6x, that's 8, 16, 24. This is 5x minus 15. I'm going to move the 5 over, so I have just x, and I'm going to move the 24 over, so I get x equals 9. Alright, let's look at number 16. Which conclusion does the diagram support? Well, from this one, it's exactly the same as the last one, right? These lines are eventually going to intersect. Let me just put that in there, just so we can see. And now, every one of these creates a different triangle. And just like in the last problem, we can follow that same rule. So let's see if this is AB underneath BC. Yeah, this is going to actually be the answer here. AB is on the left and BC, so it's going to be, now I'm writing this as bottom and top because I don't have numbers. I don't actually know which way these are going. I mean, I can see it, but proportions work no matter what word I use. And this way, I just want to make sure that FE is the bottom on ED. And it is. And I know from that same theorem that this is going to have to be the case. If you're using these two, this is saying that AF is 1/2 of CD. We don't know that at all. That is a modified, incorrectly version of a theorem that we did learn, but we never actually learned that theorem. And BE being 1/2 of CD, well, we can see, even though we're not supposed to trust our eyes, that CD is shorter than B, but not by 1/2, and that's not what our theorem tells us. Our theorem tells us that we have to look at the sides to make that judgment. And since we have no congruency marks, we actually can't use that anyways. And then if I look at BE over CD, I never learned anything about the horizontals being proportional. And AF over BE. So that is another theorem that we don't even have. So that process of elimination leaves me at A still. All right, let's look at number 17. I just recorded it, but never hit record. So I just did it without recording it. All right. I call this the Tuski method because he just said, let's do it this way in class, and I like it. He saw that these two triangles are the ones we need to find the proportion between. And he said, look, Mr. Fimble, x is already over 24. X plus 10 is already 54, over 54. Those are the corresponding parts if I flip E to G. So I'm just going to write it just like that. And I couldn't be happier with that thought process. Because these two are congruent, we could just flip this over and see that those are corresponding and these are corresponding. This is going to give me 24 times x plus 10 is equal to 54x. And then I'm going to distribute this in. I'll get 24x plus 240 is equal to 54x. Subtract 24 from both sides and I'll get 240 is equal to 30x. When I divide by 30, I'm going to cancel those zeros, and I'm going to know that 24 divided by 3 is 8. So my x is equal to 8. Can I check this? Of course I can check this. Here's how I'm going to check it. Plug in for my x. This is going to be x equals 8, and this is going to be 18. And what I'm going to do is, as you'll already see on the calculator, I've got my answer up. Nope, I don't. That's for a whole nother problem. So here, to go from 24 to 54, I have a scale factor of 0.4444. Right? Let me move the pen so I can have control over this. To go from 24 to 54, I have the scale factor of n equals, well, 0.4 repeating. That's obviously going to be smaller, so that means I need to take this number times n, and I should get this number if it's correct. So with this still being up, but not that, hit times 18, and I get 8, so we've done this one correctly. Alright, and for our last one, given triangle ABC, what is the value of x? Here we have two triangles again, and we can go with what I'm calling from now on the two-ski method again. Since these are equal, I can just reflect over this to see what parts are corresponding. This is going to put my 4 over my 7 and my 14 over my x. This is going to give me 4x is equal to 24 would be twice, 56 would be 4 times, and then let's just say 84, but that's not it. 7 times 14 is 98, and then divide this by 4. This is going to be 24 and a half, because 25 times 4 is 100 minus 2, which is half of 4, but let's double check. Oops, where are we at? Oh, because I have this on. 98 divided by 4 is 24 and a half. So that's our x, 24 and a half. And should we check it? We're just going to ask ourselves is, well, we could do that, but let's stick with two skis method. Is 4 over 7 equal to 14 over 24 and a half? 4 divided by 7 would be possible if I didn't have that on. Is equal to 571,428. 571,428. These are correct. They have the same scale factor between them. And that is topic 7.